And welcome to our second tutorial. In this second tutorial, we will still be solving rational equations, but this time we must check for our extraneous solutions. So let's flip over to our example 4. We have this rational equation. We need to find the LCD. Of course, that's still always what we're trying to do first. So I'll put a little LCD here. This time the LCD is hiding a little bit more than the other examples we saw in our previous tutorial because we need to factor some denominators. This is a difference of two perfect squares. That factors into x plus 1 times x minus 1. Remember, it's a whole lot easier if you can see what the factors are. I'm going to scratch this out now that I've rewritten it in its factored form. X plus 1 is just x plus 1. This has a GCF, so watch out for the GCFs. Pull that out, and we're left with 2 on the outside and x minus 1 on the inside. And I'll scratch that out since I have my new denominator there. So now let's look at all of our factors that we need. First thing I see, I always like to start with the number. It's the only number that I see is a 2, so I'm going to put 2 in my GCF. My LCD. I have an x plus 1, and this one also has an x plus 1. And this one does not, but I'm going to need an x plus 1. So there's that. And this one has an x minus 1. This one does not, but this one does. But again, I just need that first x minus 1, just one of them, because that's the most that I see in any one denominator. So there's my LCD, 2, and x plus 1, and x minus 1. I'm going to take that LCD, and I'm going to multiply it to the top of each of the fractions that I see. Sometimes this LCD is a little bit longer, has more factors. That's why I sort of slant it up here so I can fit it, all of them. I always start with a little dot right there to remember that I am multiplying. And since I'm multiplying, again, that makes everything factors, and I can cancel out common factors. Now that I've written it at the top of each of the fractions at the numerator, I can cancel out any common factors from the numerator with any common factors from the denominator. And I see the x plus 1 will go away. I also see the x minus 1 will go away. That's kind of nice. The only thing that's left is the x times the 2. So that's 2x. Then my plus sign. Don't forget the symbols that are already there in my equation. The next fraction, the x plus 1 will go away, but nothing else. Okay, so the 2 times the 2 makes my 4. And I still have the factor of x minus 1, which I will keep in parentheses, and then my equal sign. My final fraction, I see that the 2 is going to cancel away, the x minus 1 is going to cancel away, and I'm left with a 1 times an x plus 1. I can do that quickly in my head. 1 times x plus 1 is just x plus 1. Great. So that one step is very helpful because now all of my denominators are gone, and I just need to solve this equation. I'm going to distribute. Get my like terms together after that. I have 4x minus 4. My like terms are 4x and 2x and 4x makes 6x. Now that both of my sides are cleaned up, I'm going to choose this side. I like to always choose the left side if I can. So I'm going to subtract the x. That's to put my variables. I like the variable to be on the left side. There's my 5x. And maybe at the same time I'll get rid of the 4 to the other side. So slash that out and I've got 5 over here. And I'll divide by 5 and I'll have my final answer x equals 1. Now please don't be quick to box or circle or identify your answers because we must check the denominators. And in this case, something happens. When we try to plug a 1 into this equation, we can plug the 1 into this denominator because 1 plus 1, that's fine. 1 plus 1 is just 2. But we cannot plug a 1 into this denominator. Think about this factor right here. If I plugged a 1 in here, I'd get 1 minus 1. And 1 minus 1 is 0. And 0 times the other factor is 0. And denominators cannot be 0. So though we thought that this was going to be the answer, this is not the answer. And since that's the only possibility for answers, we actually know that there are no answers. I'm going to put my null set symbol. This is one of those extraneous solutions. It does not work in the denominators. Now, it doesn't need to make every denominator equal to 0. It just needs to make one of them 0. In fact, if we tried to plug it into this denominator, it still wouldn't work. 1 minus 1 would be 0. You cannot divide by 0. I'll go ahead and put that as a note if you didn't already. Cannot divide by 0. So that's our first one where our solution actually did not work. Let's look at example 5. I feel like something's missing in example 5. Oh, I see it. This middle term is not actually written as a fraction, so I'm going to put it over 1 just so I can see numerator and denominator of all three fractions. That's a little bit better for my eyes. LCD, not too difficult here. I see a factor of x minus 2, and that's really the only factor that I see, so there's my LCD. I'm going to multiply by x minus 2. I'm going to multiply by x minus 2. And I'm going to multiply by x minus 2, all the fractions that we see. In this case, the x minus 2 will actually cancel away, and I'll be left with the numerator 5x, and then an equal sign. Nothing cancels away from this denominator, so I'm just left with the 7 and the x minus 2. Some people might distribute as they write this part. I'll save that for a step. Plus sign. The x minus 2 does cancel away from this third term, and I'm just left with 10. Okay, doesn't look too difficult. Let me distribute, unless you already have. I have 5x equals 7x minus 14 plus 10. Let's get our like terms together. A negative 14 and a positive 10 can combine on that side and make negative 4. And let's go ahead and subtract this 7x over to here. And I'll have negative 2x is equal to negative 4. When I divide by negative 2, I get what appears to be my answer of positive 2. But if you are diligent and you check your answers with your rational equations, you can see now that this is not going to be an answer. If I try to plug a 2 into this first denominator, I would get 2 minus 2, and 2 minus 2 is 0, and 0 is not a good value for a denominator. You cannot divide by 0, so therefore this is not the solution. And again, since there's no other possibilities, I have to put no solutions. I'll put the null set. That means that there are no solutions. That is an extraneous answer again. Let's see if it happens again in example 6. We've had 2 in a row now. Let's find our LCD first. Step 1 is always just find the LCD. I see a factor of x minus 3, and there it is again, so x minus 3 is needed, and I see a factor of x. I'll put the monomial part first, and then the binomial part. I need an x and an x minus 3. Ultimately, I need the pieces that will cancel away the denominators. And once I have that LCD, those pieces, I'm going to put them at the top of each of the fractions. Absolutely a fair move to do in an equation, as long as you do it to every single term. Since I've put something next to this binomial, maybe I put that in parentheses. Now let's see what cancels away. The x minus 3 is gone, leaving 2 times x, 2x. The plus sign. The x is gone, leaving 1 times x minus 3. I'm pretty sure I can do that one in my head as well. Get x minus 3. Equal sign. The x minus 3 goes away. This time I have a binomial times this monomial. Maybe I write it first like this and then distribute in my second step. That's fine. If you can distribute in your head, that's fine. You know what? I'm going to gather like terms at the same time. Get rid of that. Because I see a 2x and an x make 3x. Minus 3. Over here I get x squared minus x when I distribute. So this is a trickier equation. I know that it's quadratic because I see the little x squared. So most likely I'm going to be solving this by factoring. And if I'm going to be factoring, I need to set everything equal to 0. I'm going to choose to bring everything to this side. I like my quadratic term to stay positive. So I'm going to subtract 3x to this side. I'm also going to be adding 3 to this side. So let's see what we've got. This is going to be all gone, and that means that there's my 0. I have my x squared. This becomes negative 4x, and this becomes 3. So there's my quadratic in standard form. Let me factor. This is not going to be too difficult. There's only one option for the front, x times x. There's only one option for the back, 1 times 3, so I'll go ahead and put those in as well. And there's actually only one option for the signs. The signs have to be positive, excuse me, they both have to be the same because this is a positive sign. This is what they're going to both be, both minuses. That's the only way that it would factor if it does, and it does. And those factors are going to help me get my zeros, or my roots, or my answers. X equals 1 and x equals 3. So this time we have two answers. Or do we? Make sure that you check in your denominators. Let's start with the 1. Does 1 work? If I go back in the denominators, if I plug a 1 in here, sure, 1 minus 3, that's not 0. If I plug a 1 in here, yeah, well, 1's not 0. And again, 1 minus 3 is not 0. So it looks like 1's going to work. How about the 3? If I plug a 3 in here, 3 minus 3, uh-oh, 3 minus 3 is 0. So that means that this one does not work. So one of them does not work, but the other one does work. So sometimes you will have one extraneous answer, but another answer will work. So there we go, we'll box that in. I do have one last example to show you, and it's different from what we've seen so far, at least in the end. Let's find the LCD. This is going to be a little bit tougher too because we need to factor this middle denominator. And you know what? If you're having trouble factoring, use the rest of the problem as a hint. I bet one of these factors is going to either be an x plus 4 or an x minus 1. Actually, I think it's going to be both. X times x gives me my x squared, so I'll put my x's in the front. 2 times 2 I know is an option, but the 1 and the 4 is going to be the option that gives me 3. And it needs to be a positive 3, so this bigger number needs to stay positive, and then subtract the 1. So plus 4 minus 1 gives me the 3. You can double check, but I'm pretty sure that's correct. And it helps that there's an x minus 1 over here and an x plus 4 over here. And that's actually representing my LCD, what I just found. The x minus 1 and the x plus 4 are the two factors that I'm going to need for this problem. I'm going to multiply them to the numerator of each of my fractions so that I can cancel things out from the denominator. Just the pieces that will cancel away. And let's see what happens here. The x plus 4 goes away, and I'm left with 1x minus 1. So there it is. Then my equal sign. The x minus 1 cancels away, and the x plus 4 cancels away, leaving only that 3. And then my plus sign. The x minus 1 cancels away, and that's all, so I have 1 and x plus 4. Okay. That really does not look like a difficult equation to solve. Let's gather some like terms before we work on each side, or on, across the sides. I'll put the x first. 3 plus 4, of course, is 7. Now I choose a side to put my variables, and I usually bring them to the left, so I'll subtract x from both sides. And when this happens, something weird happens. X minus x is actually 0. It's gone. So the only thing left on this side is a negative 1, and the only thing left on this side is a 7. And supposedly there's supposed to be an equal sign in between there, but we all know that negative 1 and 7 are not the same numbers. So that is not true at all. This is a false statement, and sometimes this is what's going to tell you that there are no solutions. When you do your math and your variables all cancel away to 0, what you're going to be left with is either a false statement like this, where you have two numbers that are not equal, so you'll say no solution, or you might have a true solution, a true statement. Sometimes, now this is a different problem, let me just come off to the side. Let's say we came down to we had something like x plus 3 equals x plus 3. And when we subtract the x, we get that 3 is equal to 3. This time, that would be true. And if it's true, then we have infinite solutions. If I could spell infinite solutions in this case. So there are two cases. Again, this has nothing to do with the problem that we just did in example 7. This is just another example. We'll call this example 7b, I guess. Okay. So in this case, we got down to a completely false statement, so there are no solutions. In this case, if we had this case at some point and we had a true statement, that would mean that there would be infinite solutions. So this is the other option. I'll put or. Thanks for watching this tutorial. I know we have some stuff to practice in class, and I'll see you then with any questions you might have. See ya.